Assalamualaikum to the examiners panel. My name is Muhammad Rafi'i bin Sukar and I will present my final year project 1, and the topic for my final year project is effect of ultrasonic agitations on the electrode depositions of nickel silicon carbide with different silicon carbide contents. First of all, I will start my presentations with the introductions. Protective coating were first development in the last 2 decades in order to avoid corrosion attacks on materials. Particle reinforced composite coating are widely employed in a range of industrial applications, including aerospace, automotive, and oil and gas. Many coating process investigations have indicated that the development of composite layer improve the physical and mechanical qualities significantly. Electrodeposition is a coating grow technique that involves the formation of metallic layers on a material surface by an electrochemical operation using electrolytic depleting metal ions of an electrolyte. This procedure is widely considered to be one of the most effective methods for reducing corrosion rates in the industry. Furthermore, this procedure is a well-known approach for today's use because of its low cost, ability to be controlled at normal pressure, rapid deposition rate, and economic viability when compared to other coatings. Because of their excellent mechanical properties, nickel silicon carbide coatings can be used in various applications including corrosion and wear resistance. Nickel silicon carbide coating, for example, have been marketed and widely used to protect friction components, cast mold, internal combustion engines, and on oil and gas pipeline system, and among other things. Ultrasonic agitation is a common technique for dispersing nanoparticles in the platinum medium for preventing agglomerations during electrode depositions. Furthermore, plating factors such as electrolyte temperature, ultrasonic power, current density, particle concentrations, and plating buff composite have a significant impact on the performance of nickel-based composite made with ultrasonic electrodepositions. Ultrasonic power substantially impact the microstructure, phase structure, surface morphology, and other aspects of the composite produced. Ultrasound has been shown to improve both the electrodeposition process and the properties of nickel silicon carbide when used in electrochemical operations. For the problem statements, the most typical concern with the materials have been found as wear and corrosions. Several corrosion problems are common in a variety of industries including automotive, railway, manufacturing, and oil and gas. The importance of corrosion attack frequently leads to system failure and inefficient operations. In order to control the rate of corrosion in industry, it requires more preventive technique. Corrosion assault on such goods can be avoided by preventive methods such as composite coating. Engineers are constantly looking for ways to improve many areas in the world of engineering, since better approaches to generate a more effective environment are currently being developed. To prevent economic losses and limit equipment damage caused by corrosion in industry, it is critical to improve and understand corrosion behavior. Thus, the goal of composite depositions in this study is to reduce the corrosion rate on material while also improving the substance quality. The objective for this project is to characterize the nickel silicon carbide electrode deposition coating with different silicon contents, and is to compare the wear and corrosion behavior of nickel silicon coating. For the scope of study, firstly, the anode and cathode are graphite rod and mild steel during electroplating respectively. And the second, the electrode deposition coating parameter comprise of 3 different silicon carbide contents of 10 gram per liter, 20 gram per liter, and 30 gram per liter. Whereas the bath temperature, stirring rate, and deposition time are all fixed, which is the bath temperature is 50 degrees Celsius, and for stirring rate is 200 rpm, and the deposition time is 1 hour 30 minutes. Third, the phase of electrode deposition coating and the presence of nickel silicon carbide were determined by X-ray diffractions, and the microstructure is observed by scanning electron microscope. And the last is the wear behavior will be monitored using weight loss method, while electrochemical tests for corrosion behavior. This is the flowchart for arranging my experiment. For the first, we start on the sample preparations. Sectioning is the first step for mild steel. This procedure was used to prepare the specimens for electroplating, which require tiny fragments of material. Electrical discharge machining wire cut is the appropriate machining for cutting small sections of the workpiece using the EDM machine. Cut the mild steel material into a small size of 10 mm times 10 mm times 5 mm. Upon sectioning, the material must be ground to remove any excess metal and flatten the sample surface. Surface grinding smooths the flat surface of metallic material with belt. And then polishing serves the same purpose as grinding in that it removes any dirt or excess metal from the sample surface. The specimen must be polished until it has a mirror-like appearance. And then cool mounting is to protect the coat material during preparation so that optimal heat retention can be achieved. Mounting the unusually shaped specimen also makes it safer and easier to handle. Next, after finish doing the samples, we go to the electrodeposition testing. One of the most crucial equipment for doing electrodeposition research is the beaker. This is because the electrodeposition process will take place in the beaker, where the anode, cathode, and electrolyte solution will all be present. In order to complete the circuit, an electrical source is also required. This experiment requires additional equipment such as ammeter, clips, rod holder, and magnetic mixer. A magnetic stirrer is a laboratory tool that is commonly used. This magnetic stirrer is typically used to stir or bitter mix a solutions. The laboratory clothing code, which includes laboratory coats, gloves, and face masks, must be followed to ensure that no accident occur while conducting studies. The composition of the standard nickel consists of nickel sulfates, nickel chloride, and boric acid with different silicon carbide. Cathode construct of my steel with dimensions of 10 mm times 10 mm times 5 mm were placed in the same vertical plane as the anode. As the anode, a graphite rod was employed. Both electrodes are 3 cm to 4 cm apart and are immersed in the beaker. The beaker was placed on the magnetic stirrer and filled with a nickel sulfate, nickel chloride, boric acid, and silicon carbide concentration electrolyte solutions. A magnetic stirrer is a laboratory instrument that was used to stir the electrolyte solution at a consistent rate. The stirring rate and deposition duration in this experiment were set to 200 rpm and 1 hour 30 minutes respectively. The cathode and anode were held together by a wire clip. The wire clip also served as a connection point between the power supply and both electrodes. The power supply electric current will be set according to predefined specifications. To ensure that the current rate in the electrolyte did not change during the experiment, a standard multimeter was employed to measure it. After finish the electrodeposition coating, we find the surface or morphology of all coating that were evaluated by using scanning electron microscope. The scanning electron microscope is high resolution instrument that has the capability to generate magnified image from visually any type of specimens. The specimen was placed under the microscope and it is examined by using secondary electron detector. X-ray diffraction is a phase detection method for crystalline structure. The relative peak intensities are used to determine the relative amount of phase in a coating. Based on the XRD data, the average nickel and silicon grain size were calculated. And then we doing the micro hardness test. Because micro hardness tester was used to determine the hardness of nickel silicon coating. A diamond indenter was used to apply 100 grams of fluid to the specimen surface during micro hardness testing. The sample surface should be free of staining and perpendicular to the indenter axis. An optimal microscope was used to measure the size of the resulting depressions. Hardness data can be analyzed after 10 seconds of mean stresses applied beneath in the indenter. A microscope can be used to detect hardness measurement. For the corrosion test, we use the electrochemical test. With the help of the potential state device, the electrochemical work in this study was possible to be complete. The potential state is an electrical device that regulates the voltage between the reference electrode and the working electrode in an electrochemical cell. This device works by infusing electricity into the cell through the auxiliary electrode. Furthermore, in this experiment, the cell layout includes an electrolyte mixture as well as three types of electrodes, which is a counter electrode, a reference electrode, and a working electrode. The counter electrode was platinum wire, the reference electrode was silver or silver chloride, and the working electrode was the samples. All the electrodes were submerged in a 3-gram sodium chloride electrolyte solutions. The current supply flow through the counter electrode was then measured and the data was analyzed. Following that, the tougher polarization test was performed at a 10 MV seconds scanning rate. And last, we doing the wear analysis. The modified Macon grinder and polishing machines was used to run the test over a distance of 100, 200 and 300 meters. The sample is affixed to the machine holder before testing with a force of 20 Newton. Both the wound track and the pump that supplies the silicon carbide slurry run at a speed of 200 rpm. 3 grams of silicon carbide powder were combined with 1 liter of distilled water to create the slurry, which was the extensive agitated using a hot plate and magnetic stirrer. That's all the presentations from me for topic research experiment on my final year project. Thank you.